have the privilege of introducing Tom Hepner, who is with IBM, and he will tell us about the mysteries and benefits of virtualization.
Yes, good morning, everybody. I want to thank Caltrans for closing a lane through Petaluma. So I've been sitting on the freeway from San Rafael for the last hour. And so if you'll bear with me for just a minute. And,
Been there, done that.
what's that?
Been there, done that.
Yeah, I'm sure. I mean, when are they going to widen that freeway or put in some decent mass transit or something? As Mr. Ledden, is that right?
Yeah, the dean.
Ledeen, thank you. Said, my name is Tom Hepner, and I'm just going to talk while I find the presentation here. My name is Tom Hepner. I'm from IBM. I've been with IBM for 25 years, and I work out of the San Jose office, Almaden Research. I support one of the Tivoli products, which is Tivoli is IBM's brand for software storage these days. Although, like anything within IBM, it tends to organizations change quite frequently, and in order for us to stay up with the marketplace, it's really an interesting situations how our organization tries to stay up with that. And let's see here. One more time. Okay. Are you all computer science majors? Is that why we're here today, pretty much? And how many of you are familiar with virtualization technologies? You've all seen that? How about Vmware in particular? Okay, great. There's some familiarity with that. All right, come on, I need to get my machine. There we go. To be able to see that. All right. Yeah, have you any questions on that? Unfortunately, that was the wrong presentation. Let's see here. Let me go back. Here we go. I'm going to give you this one here. I've been working with the TSM product, which stands for Tivoli Storage Manager, for about 12 years. It started out as I'm going to flip through some of this earlier stuff. TSM started out as a product called WDSF, workstation something. Had to do with it was IBM's first open software program. Turned into ADSM. Then we bought Tivoli, so now they thought it felt like a Tivoli product, so they threw it over to them. And what TSM is, Tivoli Storage Manager, is our primarily open software to do storage management. And a lot of people will say backup and recovery when they talk about this type of software products or applications. And so in the marketplace, and I don't mean this to be a sales pitch in any way, so I'll mention in the marketplace you've got Tivoli Storage Manager, you've got Net Backup, the Legato product, and Veritas. Those three companies, of course, Legato was bought by EMC, and Veritas I think was bought by Symantec now. So, but those are the three big players in terms of backup and recovery software. Now, we try to distinguish ourselves in that we try to be a real storage manager. So, as you know, there's lots of ways you could back up your machine and you can make copies of files. The question is, what do you do with those files after you back them up? Okay, you usually have a business case or some sort of edict comes down, whether you're a business or whether you're a government agency that talks about how many versions you want to keep of things and how long you want to keep them. Now, we've recently, in the last few years, had a huge influx of regulations pushed down on the industry by the government, having to do with how long you keep these records, and I think a lot of it goes back to some of the more well-known cases we've seen in the news about email and who sent what to whom and this and that. So companies now are really hanging on, especially to their email, for the specific amount of time that the government regulation says that they have to keep it, but no longer. So as soon as that time period exit, they get rid of that stuff as soon as they can, because you don't want anything extra hanging out there in terms of a legal problem. Now, so TSM, if you have, we distinguish our application between our server and our client. So it's a client-server application, and we have either a client or an agent that sits on usually servers. This is a product that goes into an enterprise or a very large system, but we could back up a laptop or we could back up a workstation. Primarily servers. It's a rather expensive product, so you probably wouldn't use it for your home backup solution. However, we do have a lot of universities that use our product. Do we happen to know what you have here, by any chance? Anybody? What, Net Backup? Okay. I know a colleague of mine just got back from Oxford, England, and he was telling me about Purdue's. Purdue has been one of our customers for a long time, and they have huge implementation of TSM. So, last thing I want to say about TSM is just to give you some familiarization. We have the client, we have the server, we have multiple technologies to exploit SANs and exploit different things like these big storage arrays that we're seeing now, either from IBM or EMC, Clarion Disk, and IBM Sharp, DS6000, 8000. And these are these big black boxes that sit in a raised floor room that have terabytes of data behind them, and they have they all run the SCSI 2 or SCSI 3 protocol within them, so they usually have at least 2 processors just for the box of disk, and it gives you the ability to, say, send a request to the disk itself and say, hey, back yourself up. I don't want to have to do it. And so there's a lot of technologies. One of the main technologies that we talk about is LAN-free. So in the past, say 5 years ago or more, all backups were done across the LAN. And, I've been around long enough that when I started out, we were doing, 10 megabit and 16 megabit token ring and that sort of thing. So doing backups was a real chore just to get the stuff through the network. So now we've gone, 100 megabit. That was a huge improvement. Then we got 1 gig, 2 gig, and now we get the SAN. So we've got all of these different storage area networks. And is everybody familiar with that term, storage area network? Okay, so that's a network that is comprised of your storage devices like these huge disk boxes and tape libraries where they're all connected usually on a fiber channel, and they're running 2 gigabit communication or higher, now all the way up to 10 megabit, and it's going higher than that. So you've got this storage area network that where all your devices are connected to each other. And it's a great advantage because then you have a cheap way of spreading out storage to a lot of different consumers in your environment. However, there are some gotchas in that as far as data integrity. So you want to be very careful about somebody else clobbering your drive, And if you have, say, a Windows 2000 machine and you bring it up on a SAN and you say, here's a disk that you can do. Well, what's Windows 2000 going to do by default? It's going to say, okay, I own that disk now, thank you very much. And then anybody else that had anything written on that disk has now just become invisible to them. So there are things within the SAN environment that you have to keep track of, and it's probably one of the tougher things as far as implementing VMware and TSM or any other product, because what I'm going to talk about today primarily is something called VCB, or VMware Consolidated Backup. Okay. If there are any more questions about TSM, throw them out there, but let's talk about VMware and see how it works. This is just a visual that I threw together that talks about VMware. The dark blue is actually the hardware. The lighter blue is the host. I said host Linux. There's some confusion on my part probably about whether or not the VMware server or on ESX, we're talking, there's 2 flavors of VMware. The old name was GSX and ESX. Now they call it VMware Server, and the ESX server is the new name. So ESX 3 point whatever and above is what I'm going to talk about here, or what the current technology is from VMware. It's a wonderful product. The fact that this whole technology was invented by IBM back 30 years ago, and we ran it on the mainframe, and then we totally let it die, and then somebody else came along, VMware, and they picked it up. And of course, Windows 2000, what do they have in this arena? Virtual server. Have you anybody used that? So that's a way that you can implement virtualization just on a Windows platform all by itself, and it's similar. So what we have here as far as virtualization is that you can bring up these different OSs underneath the host machine. So I will either refer to these as guests or VMs, virtual machines. Okay, just a quick slide as far as what we need to be able to work on these things. Installation, we really don't have time. Here's the thing that is very useful in terms of TSM technology, in that it allows you to administer a TSM client, say, or a group of clients virtually anywhere in your network. So it has this acceptor daemon that it's talking about just allows you to bring up any web browser, or most web browsers, and you can use that to administer a particular client. And again, the client, when I refer to that, that's the machine with the data that you're trying to protect. Okay, let's talk about some different types of backup methods with VMware. Okay, remember what you're doing is you've got this host machine that is creating all of these virtual operating systems underneath it. Okay, and in terms of scope, what you're talking about is, let's say you have a fairly large server with, say, 4 processors and 12 gig of RAM. So customers are putting anywhere up to about 20 to 30 VMs on that machine. And then these are great, it's a great way of doing testing. So for instance, when you have any application, any large application in your environment, you know, it's going to continually come out with new versions. So one of the things that we run into all the time with customers is, you know, their test bed. What do they have for a test environment? Because if you have real production data going there on a day-to-day basis, you really don't want to muck around with putting a new version on just in case there was a bug in there that the company that produced, not that IBM would ever produce software with any bugs in it, but if this application had a bug that just happened to clobber a bunch of your data, you just don't want that to happen. So VMware is a great way to create these virtual machines that you can put new software versions on, and you can hammer them with all kinds of test cases, and if something blows up, you just reboot the machine again, virtually of course, and you're back in business. So it's wonderful for that. It's also great in that you have, let's say you have one machine, physical machine, but you want to have multiple operating systems. You want to have some Linux and some Windows and even NetWare. So if you want to be able to provide that to your end users, that's a great way to do it. Okay, but now how are we going to back this stuff up? How are you going to protect that data? Well, you can do it on a file level incrementally. You can do a full guest VM backup, and there's different ways that I can talk about here. And then there's this thing called consolidated backup integration modules. Okay, file level granularity. In order to achieve this, what you would do is you would take your individual backup client or agent and you would install it on each and every VM you have that you want to protect the data for. And the advantage of that is it gives you the full capabilities to either back up or restore individual files. This usually, we don't see this that often because the VMware machines are usually kind of a crash and burn sort of thing. So if they do need to be restored, they usually restore the whole thing, which is that full VM guest that I saw before. But this does give you the ability to do that. Another thing that I'll mention about this that could be a gotcha is licensing. So now that if you have all of these VMwares, VM guest machine, every piece of software that runs on those machines need to have a license. Now, in terms of licensing for TSM, I can't speak for the other products. The way it is currently, and this does change every few years, the licensing for TSM has to do with the number of processors on that machine, whether it be a dual core processor, you know, just a single chip that plugs in, but you have actual two processors, or you have multiple processors with multiple chips. That's the way the licensing goes. So you could have a problem. So it's a consideration. I guess the point there is you can have as many VM guests as you like because it's related to the processing or the processor. Okay, now in terms of backing up, the first method that we're going to do to back up this data is with the full guest. Is you actually have to shut it down. Now with VMware, notice I've got the .dsk shown that's for the, say, the lighter version, or the version that you can go to the Vmware, and I've got some links in here that you could do this. You can go and you can download, I think, a free version of their machine, of their VM guest. And that's what it would be comprised of, is a bunch of .dsk files. Now, if you're on the enterprise level, it's a VMDSK or something like that. I'll see it here in just a minute. Different set of files. So what you would do is you'd simply shut that virtual machine down, back up that group of files, and then bring it back up again. And then you have encapsulated the entire machine. And the advantage is, because you've shut the machine down, all of the files are closed, there's nothing open, nothing is changing, so you're ensured data integrity, which is really the most important thing that you really should be worried about. Disadvantage is, it's also the slowest way to capture a backup. Now, the second way to do this, everybody here familiar with Linux? Right? So, you know, Linux, Unix, very similar. Because we're running under this Linux kernel on the host, what you can do is you can back up an individual VM guest and then just copy all of those files that we talked about with the dd command. And so that way, as you can imagine, the .dd command is going to run much faster than an actual backup product, because, for instance, at the heart of TSM, which is probably one of the slowest products to do a backup, at the heart of TSM is our database. And what we do is, when we back up a file, we keep track of all of this metadata that identifies where a backup goes. So if you have TSM, you never have to worry about where the backup went in terms of an end user. You don't have to remember where the library is, what tape volume it went on, or what disk pool it went into, or anything like that. All of that is transparent to you as an end user. But because of that reason, there's a lot that goes in to backing up a machine than just copying the data. So that's something to keep in mind. So with this second method, you can shut down the VM, do a DD, back up the copies, bring the VM guest back up so that your end user gets that machine back, and then you can back up those files with your backup product at your leisure. Okay, and there's the advantages that I just kind of talked about. Probably the biggest disadvantage is then you need some extra space. Okay, depending on how big your VM guests are. Of course, you can rotate them so that you're not going to do them all at one time. So you don't need that much extra space. And then this is just a chart that shows the bottom line here. Shows you that the DD command is much faster. Okay, this is another older tool, the suspend command, that I don't want to spend much time with because VMware is moving away from that. But I do want to talk about this freeze command just for a minute. How many here are familiar with basic database principles? Recovery logs, that's transactional logs, that sort of thing. Okay, so what VMware has instituted here is that, let's say that you have your VM guest and it's up and running and it's doing reads and writes to your disk drive. Okay, and you want to back up that disk drive. So VMware instituted the freeze command. So what it does is it diverts all of the writes to the disk, not the reads, but it diverts any writes to that disk to a redo log. Okay, so that during the time when the machine is frozen, all of the writes go to the redo log. The backup is done on a disk that doesn't change, so it's a point-in-time backup. All right, so if let's say it takes you 30 minutes to do your backup, and in the middle of that backup, some of your files changed. Now, you're not going to get those changes because it's a point in time from the time you started your backup. But then as soon as the backup completes and it goes through a thaw process, then all of those writes that went to your redo log get reconciled to your primary disk, which is, of course, your virtual disk. And then the machine is back under normal operating system. So I just want to point that out because the freeze command is no longer used, but that same technology is what they're relying on today, as we will see here in just a minute. And there's the advantages and disadvantages. How are we doing on time?
15 minutes.
Okay, that's what I was afraid of. I'm going to skip past this, some of these hints about individual things because I want to get to this. Here's an error that you would see if you don't shut down the virtual machine and you try and back it up from our client. Okay, let's talk about consolidated backup here. Okay, here is a picture of what you might see. That gray block, the backup server. Okay, I'm going to talk about that in a minute. Let's look at this lower portion. So the gray down here that says Service Console, that's what you're going to have with VMware, with your ESX server. That's the same thing I'm talking about. It resides, this all resides on one machine. And then you have these multiple VMs or guests on that. Now, VMware has introduced this concept of a backup server. So what's that for? One of the primary problems that we and VMware saw when we started rolling out these VMware machines is that, remember, you have one machine with limited I/O capacity, limited CPU capacity, and limited network capacity. But you had multiple machines that were going after those resources. So that was a problem. So people would start loading up VM guests on their machine, and the first thing they usually run out of is CPU. So then things start paging, and everything slows down to a halt. So to make a long story longer, they decided to remove the additional load of actually backing the machine up to a different separate machine, and that's our backup server. So again, here's a way you can put this agent or client on each VM guest, and then you can back that up directly to your backup server. And yeah, I'm sorry, I've confused a couple of terms here. The backup server would be the TSM server in this case. And I'll tell you where I made a mistake in just a minute. Okay, those are the file system level backups as we talked about. Or you could install it, this agent again, the same agent, and this would be separate from your VM guest on the ESX machine. So we have a Linux client, as do all the other backup products. Install it there, and then you can back up the entire VM, as we talked about before. Okay, and then there's our tape library that the backups will eventually go to. Okay, now let me get here we go. So let's go through. Here's a VCB installation. We saw there's our ESX machine, and now here's the disk with the VM file system down there as shown. Okay, now backup proxy. That's where I got off the mark here. We have our backup proxy, and this is the thing that's going to take the load off of all of our VM guests and the ESX server. It's going to take the load off of it. Okay, now we have the TSM client installed over here. All right? Now, how many is familiar with snapshot technology? Snapshot technology, or flash copy, maybe called that way. That's a technology to take a snapshot of a disk, and what you do is it's really taking a copy of the bitmap of that disk that says where each and every file. You have your raw disk, which is just a bunch of bits, right? You got your raw disk, and then you lay your file system over it, and that's really a template that shows where all your files are and all that. So really, when you do a snapshot, you're taking that template and say, okay, now I've copied your disk. Well, as you can tell, it's very fast. You haven't really moved any data yet, but you just have pointers to all the real data. Okay? Then as time goes on and files do change, the snapshot technology will recognize, oop, this block just changed. And it zaps that block over to the snapped volume. And it's very fast because it's done on a block level. So, and again, this is accomplished through the SCSI-3 technology that allows a disk subsystem to back up itself. And so what we do is we give this backup proxy the ability to see this now SAN attached disk here. So we have a snapshot copy over here. And there's our library that we're going to, once we've told VMware that we're going to do this VCB backup, and by the way, it's really the foundation of VMware is a executable called VCB mount.exe, and that's really the heart of what they call the VMware or the VCB framework. It's really just one module with a great big string of parameters that you can pass to it, and it does everything from quiesce the database in VMware to say, okay, hold on, wait a minute, I got to get ready, I'm going to do a backup, don't get excited, to actually do the snapshot itself, and also do the mount of that volume onto the backup proxy. Because before you start the backup process, if you were to go into the backup proxy and look to see what's on there, you wouldn't see anything, because you don't want to have it attached permanently to that machine. There's no need for it. So now we're starting our backup, and what's going to happen is the VCB is going to be running, TSM client is going to be running. It's going to use a thing right now called the TSM-IM, or TSM integrated module, and there's one for Veritas and there's one for Legato. I don't know if there's others, and they're all basically just a bunch of scripts. In our case, what they did was they went through and they saw how TSM worked, and they said, oh, okay, TSM has this ability before a backup to send a pre-scheduled command, and that's what it's called, pre-sched. That's the name of the operation. We have the ability to send a pre-scheduled command to the client to issue operating system commands. Okay, and that's part of the TSM scheduling backup technology. So that's what happens. So there's that pre-schedule command. It does this sync. We create that redo log that I mentioned earlier. So now all of those writes that were going to that volume by the VM guest, say VM1, now all of those writes are suspended to that drive, and they're sent over to the redo log. Okay, once the backup is complete, then we've got to break the chain that we created before, and that's what the post schedule command. And I think there's a mistake in the slides here. That post command shouldn't have come in yet. But anyway, this is where it sends the block list over that says this is part of the snapshot technology. And then we actually have it there, and we can send it to our tape library. Now, in the case of, if we want to back up the entire VM guest, you can also do that, and it's pretty much the same process. The only thing that's different there, and this is a little quirk about VMware, in that when you want to back up the full machine, and this is really a gotcha, if you're ever going to do this and put it into production, this is something to think about. It actually does a copy of this entire volume, however large that is, and it's going to send it up here, and by default it sends it up in 2 gig chunks. Now it does that because some backup products can't handle files larger than, or objects I should say, larger than 2 gig. Our product can, but in any event, it copies everything up there. And we can tell it, just do it in 1 big chunk. But it still has to copy everything. So if you do the full VM, that's kind of a glitch, I think, in their technology. And there's a bigger one that's coming up that I'm going to tell you about. But I think they're going to get there, because I think VMware is a wonderful product, and it's going to continue to evolve. All right. So I will end talking about probably the biggest glitch that VMware has currently, and that's the fact that you can't do a restore using VCB. Okay, you can do a restore, that's no problem. You've got the data, but if you can't, they don't have a path. Let me get back up here. They don't have a path this way through the client. You have to do something like this, where you know you got your data over there, so you have to do a restore either from a VM guest or from the service console. As I showed before, you can have 2 places. Then you can go to your storage manager and get it back. And again, that's a kind of a hole in their technology that I think they're going to fill. Now I've thrown a lot of stuff at you, so let me just open it up for questions to see what anybody has as far as that goes. All that pretty clear? It usually takes about an hour and a half to do the presentation. Go ahead.
Now with these last backups that you described, after you do a restore, am I correct in thinking that when a virtual machine comes up, it thinks it crashed?
No. The way you do a restore is you shut the machine down and you go to the service console, and then you say, well, there's a couple of ways you can do it. You can either just shut the machine down and restore any one of those .dsk files. You can do that. Or if you want to do the whole machine, it's like you tell ESX, hey, I need a new machine. And you go through that process in the console. And one of the choices that you have is, do you want to carve out some new disk, or do you want to use some disk that you already have? And so what you do is you restore some disk, and then you tell ESX, oh, by the way, use this disk over here. And you've restored it, and it comes back up, and everything's honky-dory. That makes sense? There was one other thing about restore that I wanted to say. Oh, last thing. It's a really good way to clone machines. So if you want to create an image, back it up, then you can just restore these different clones, put them where you want, and then take ESX and say, okay, here's number 1, 2, 3, 4, 5. And then they all look exactly the same. Any other questions? Any answers?
Thanks very much.
Okay, thank you.